Hi, this is Francis from A+ Tutoring. In this session, I'm going to show you the question in the past final exam 1, number 3a. Now, this integral for sure is improper integral. It's from 4 to infinity. Now, what I want to check is there any other number than infinity that is improper? So first thing that you have to check is the denominator, x squared minus 2x equal to 0. So I factor out the x, I get x minus 2 in the bracket equal to 0. So I know that my x is equal to 0 and x equals to 2. So these are the two numbers that will make the integral not able to resolve if it's in between these two numbers, 0 and 2. But here, the interval is from 4 to infinity. So basically, the only improper value is the infinity here. So this is what you need to check to see if your interval is correct or not. Now that I have this as improper, so I have to write limit of, let's say, b approaching to infinity. And then integral from 4 to b, 2 over x minus 2. I'll factorize that because I notice right away that this must be a partial fraction. So you have to do a partial fraction for this integral. Okay. Now, to do the partial fraction, you take 2 over x minus 2 equals to a over x because it's a linear function. So on top is just a constant plus b over x minus 2. Now, how do we find a and b? All you need to do is 2 equals to a times x minus 2 plus bx. Right? Now you can let x equals to 2. This whole term is 0. So all you have left is 2b equals to 2, which b is equals to 1. Now if you do that with x equals to 0, you figure out that this term is 0. So all you have left is minus 2a equals to 2, which a is equals to minus 1. So I have this. Now I have to plug it back into the integral here with the limits. So what I have here is going to be limit of b approaching to infinity, integral from 4 to b. I have minus 1 over x plus 1 over x minus 2. This whole thing is dx. Now knowing that, I know that my answer of this here is going to be minus ln of x. And this is going to be ln of x minus 2. When you see there's no coefficient in front of the x, you can just write is the ln. If you have a coefficient, then that will be extra constant. You might want to use simple substitution to figure out if there's an extra constant in front, or you have to divide. Right? So in this case, since it's 1 here, I can just write the answer without any troubles. Limit b approaching to infinity, ln, so minus ln of absolute value of x plus ln of absolute value of x minus 2. So x minus 2 here, I'll need to rewrite this as my absolute value. This is from 4 to b. Okay, so I have something like this now. And then I can group this ln here. Okay, if I group them, it will become much simpler to solve. So I have ln x minus 2 over x, absolute value from 4 to b. If you look at this, this is basically one of the identities of ln function, right? The log function is one of the properties. Now, if you plug back the b and the 4 into this here, what I have here is going to be limit b approaching to infinity, ln of b minus 2 over b, subtract ln of 4 minus 2 over 4. Now this part is just what? This is 2 over 4, so 1/2, right? This is ln of 1/2. And this here, what can you do? You know that this is going to be infinity over infinity. ln of something that, is it 1? Is it 0? I don't know, right? So what you want to do is factor out the b on top. so that it will become easier to solve. You don't want to use L'Hopital's rule here because like that will become a very complicated derivative. So let's do that on the next page here. I still have my limit of b approaching to infinity. ln, so minus ln, I believe. Well, minus is in the other one, so I can have just this. So I factor out the b. I have 1 minus 2 over b. Subtract ln of 1/2, right? Now I can drop the absolute value on the second term, so that's not a problem here. All right, so b cancel out. What I have left is 1 minus 2 over b. Now 2 over infinity is approaching to 0. So I have 1 minus 0. So I have ln of 1. So all I have left now is ln, because I evaluate the limit already here. ln of 1 minus ln of 1/2. Now ln of 1, this is basically 0. So I have 0 minus ln of 1/2. And you can further simplify this because this is basically ln of 1/2 to the power of minus 1, which is equals to ln of 2. And this is my final answer for this problem. For more information about partial fractions, about improper integrals, please visit my website goforaplus.com.